After that, this weekend, we need to do our quiz number 2. So we just complete our quiz number 1. But this weekend, for quiz number 2, we have Module 1, Part D, then Module 2, Part A, and Part B. So 3 parts in quiz number 2 this weekend. All right. Okay, all right. Module 2, Basics of Database Management Systems. So we need to learn more concepts, some more features to give us more background. When we practice SQL queries, at the same time we need to understand how things work behind the scene. Part A, more on databases and DBMS. 8.1, advanced features of DBMS. So I want to explain 3 advanced features in 8.1. The first one, transactions in DBMS. This concept, transaction concept. Here we are in the DBMS context. We understand this transaction concept. The meaning is different from our everyday life transaction. So when you talk about transactions, when you go to a bank, so the meaning is different. So in our business, in our database context, we have a special meaning transaction. So first, let me give you the definition of this database transaction, different from our everyday transaction. Okay, so our everyday transaction, your understanding is like every business action, you can call it a transaction, right? So you make a deposit. So when you go to a bank, make a deposit, and you retrieve some money. Each one is a transaction, right? Each action, you call it a transaction. But in the database context, so we have a much strict definition, because we need to consider a very important situation in business. So what's that? So let me describe. In the business world, people need to work on business tasks. So let's consider one business task. In one business task, you need to do usually you need to do several things in one particular business task. Okay, yeah. And those actions in your business task should be grouped together for one business task. And you cannot break that group. You cannot separate that group of actions for one business task. If you separate them, you may have some problem. You may cause some problem in the business task. So that happens frequently. Okay? So right now we need to define our business transaction for that particular situation. All right. So the definition of transaction in database context. Okay. All right. So we define a business task containing a sequence of database accesses that cannot be separated. So that's the general description. Yeah. So the business accesses here, we can understand a sequence of SQL queries. So let's understand that a sequence of SQL queries, that's the database accesses. Okay. Yeah. But that sequence, the whole sequence of SQL queries must be grouped together in order to complete one business task. You cannot separate them. If you separate them, you may cause some problem. Yeah. So your business task could be wrong. Something could be wrong for that business task. So here, let's use a simple example. Let's consider a simple example in business. Let's consider a sequence of banking transactions. So this transaction, the meaning here is our ordinary, everyday transaction. Okay. So the word here, it's not a database transaction. So our banking transaction still use our old meaning, everyday transaction. Okay, suppose we have a sequence of it. So in this sequence here, we just use a simple example. The first one, you need to withdraw certain amount from account A. So you have account A. Yeah. Withdraw some amount of money from account A. Okay. Yeah. After that, you need to make deposit in another account, account B. Okay. Now you complete these two banking transactions together. You complete one business task. One business task. Think about if you separate these two transactions. After you withdraw certain amount of money from account A, all right, so before you make deposit the same amount in account B, suddenly the system suddenly breaks. The system is down. Okay? Yeah. So, due to some reason, natural disaster, tornado, or some, blackout, yeah, for some reason, yeah, you couldn't complete the second one in the sequence. Then think about, you may have some problem. Yeah. So the money is not in account A, not in account B. So how do you, how do you complete, make sure your business task, the integrity of your business task is right? Yeah, so you may have the problem. Yeah. So in this simple example, you can see we don't want to separate the sequence, the SQL queries inside that sequence to define our business task. We don't want to separate. So we want to group them as one integrated object. And we need to write, here we are talking about the feature in DBMS. In the DBMS, the feature should guarantee this sequence of transactions can never be separated. Then this DBMS supports transaction, database transaction. Okay. And it is very useful in business. All right. Then, when we write programs, when we write application programs, after you learn this concept, when we write, think about it. We as programmers, we treat ourselves as application programmers. So many times you need to work on the database transactions, because you develop applications for your business, and your business require a lot of transactions, like what we are talking about here, the database transactions. So then, when you write your database transactions, you need to make sure the sequence of database accesses are grouped as one integral object, can never be separated. Okay? Yeah. So you need to do something special. So in DBMS, there is a support. Yeah. So the current, the modern DBMS, built-in support, transaction feature, built-in support, available in DBMS. For you as application developers, you need to communicate with DBMS. And you write your code to do the database transactions with appropriate communications with the DBMS. So here, let me describe the steps you need to follow to do the transactions, to do the database transactions. All right. How to implement a transaction. How to implement in your application program. So here you imagine, now you are writing an application program, one program in a business application. Okay. So you need to implement one transaction. Okay. Yeah. All right. First step, define starting point of a transaction. Because you have a sequence of database queries, which point is the starting point? You need to tell DBMS, okay? Yeah. The first SQL query, so this is the starting point of my business transaction, okay? My database transaction. So first you need to communicate with the DBMS, the starting point. Yeah. Yeah. All right. So in Java, so there is a specific way to do transaction. All right. So when you declare a transaction object, you need to call its begin method. Yeah. Transaction object dot begin. So that you set a starting point of your transaction. After that, after the starting point, then getting all right. After that point, then you enter sequence of queries. SQL queries. So let's assume after that we need to execute a sequence of queries. Right. Okay? Yeah. All right. Then provide a sequence of queries for a test. At the end, so you have starting point, and you also need to tell DBMS what is the end point of the sequence. to complete the definition of that transaction. Yeah. Yeah. How to tell DBMS? Commit the transaction. Commit. Okay? Yeah. So if we still use the Java, yeah, so here, yeah, here I use Java as example. Different programming language, the way to do the transaction, different. Yeah. But the main idea is the same. The structure, the typical structure is the same. Yeah. You need to define a block, okay? A block of SQL queries, or a block of actions. Yeah. All right, so here in Java, suppose, yeah, first we need to create a transaction object, appropriate transaction object. Okay, all right. So here, yeah, begin. Okay, method. Yeah, yeah. Actually, you put it in a try block. Okay, yeah, because this whole thing, you may have exception. So you need to put your transaction code in a try block, because you need to prepare for some exception thrown. Yeah. All right. Then after that, so you can do your normal queries. Okay. Yeah. A sequence of normal queries. All right. Yeah. But at the end, we need to tell DBS the end of this transaction. So you need to commit. Okay, commit this. All right. Yeah. Send the command commit. Okay. So then the DBMS is ready to execute all the queries defined in this transaction from beginning to end, without interruption. Okay? Without interruption. Yeah. Must complete all the queries defined in this transaction. So we close this try block. Yeah. But we need to catch the exception. Okay? Yeah. Some exception. Appropriate exception. Okay? Yeah. Then, in the catch block, when something occurs, something is wrong. Yeah. So just as I mentioned, some system, breaks down, or electricity, tornado, when something is wrong, you get exception, right? An exception thrown. Yeah. So here. So in this catch block, you need to call the rollback function. Okay, rollback function. All right, yeah. So that transaction object call .rollback. Method. So this rollback method, stop the execution and moves back to the beginning point, starting point of the transaction. Go back. Yeah. Do not execute any queries in the transaction. Okay? Go back because you don't want to do your transaction halfway. Yeah. You would rather roll back to the beginning of the transaction. Do nothing. You would rather do nothing. It's better to half of your business task. You would rather do nothing. Okay? So that's the reason we roll back. Roll back. Yeah. In order to prevent any damage caused by the partial execution. If you do partial execution, you may cause the damage in your business. That's not allowed. Okay? Yeah. So you have this exception handling part, roll back to the beginning of the transaction. Okay? Yeah. So this whole idea, yeah, different programming language executes this whole thing slightly different, but the basic idea is the same. Yeah. All right. So the last step, roll back if there is an error. Yeah. So you can see after this careful handling of the database transaction, we can preserve our data integrity. Okay? We don't want to damage our data. Yeah. So we protect our data in this way. Yeah. So you can see this feature is important in business. So when you, so here, because before you learn this concept, you may treat each SQL query as the individual query, right? So every time you execute one query, then the next time another query, okay? So you are used to this type of SQL query executions. Yeah. But sooner or later, yeah, so when you work on more and more complicated business tasks, so you need to implement business tasks using the database transactions. In Java programming, in Java web programming, you need to do a lot of programming like this. Actually, many database frameworks, they tend to put every SQL queries in database transaction like this. Yeah. So many database framework, so they put all the database queries in database transactions. Yeah. Even one query, so they put in transaction. Yeah. So they tend to do like that. Yeah. So when you see begin, commit, roll back, so that's for the typical transaction, the structure of a typical transaction, a database transaction. Yeah. So that's the first an advanced feature in DBMS. All right. Next, let me talk about the properties. For database transaction, there are two important properties. The first one is called the isolation property. Isolation. Yeah. So what's that isolation? Yeah. I need to erase a little bit. All right. Yeah. No interference from other transactions. Because in one DBMS, you may need to execute multiple transactions, multiple business transactions, right? Several business transactions executed at the same time in one DBMS. So no interference among different transactions. The DBMS must have this property, isolation property. Second property called atomicity property. Atomicity. Yeah. What's that? The idea is simple. Yeah. You look at the atom. So what's the atom? The atom particle. Okay. Yeah. No separation. When we talk about atom, so here actually it's the ancient meaning of atom. Ancient meaning, yeah, not a modern meaning. Ancient. Atomicity means no separation. Okay? All or none database operations are executed. If you want to execute that sequence of database operations, you have to complete all of them, okay? All. Otherwise, none. So, no partial executions. That property is called atomicity. So these two properties for transaction, database transaction, that feature, an advanced feature. All right, yeah, so this is our first advanced feature. Second, concurrency control, another advanced feature. So the DBMS, a good DBMS should support. All right, so what's that concurrency feature? Easy to understand from the meaning of the word, so you can guess the meaning. Support that several servers, several users trying to update the same data, do so in a controlled manner. Because in a typical business application, it's very common. Several users, they need to access and especially update. Yeah, because when you access, if you read the data, then no problem, right? Read the data if you do not modify the data. If you read the data, then you don't worry about any potential errors. But when you need to modify the data, and several users need to modify the same piece of data concurrently, in that situation, then the DBMS should have some built-in protection feature in order to preserve the integrity of the data. Yeah. So a special feature called the concurrency control feature is needed. Yeah. All right. A good DBMS must include this feature. Yeah. Otherwise, sooner or later, you may get trouble. You may cause some damage to your data. Here I want to mention Microsoft Access a little bit. Yeah. Because at the beginning, Microsoft Access, that DBMS, was designed for personal use. Personal business, small business, very small. Yeah, single user. So you can, because at that time, this small DBMS is for single user application. Yeah. Home business, let's say home business, that kind of small business. Yeah. If larger business, you should use other DBMS, not Microsoft Access. So the early version of Microsoft Access, it does not support concurrency control because single user, okay? So you don't have the situation multiple user need to modify same data concurrently. Yeah, so no such issue. Yeah. All right. So that's the old version, not current version. The current version, so they changed to, because they changed to small number, relatively support, small number of concurrent users, 225. Much better than older version. So here, I have some experience, not my own experience. I talked to some people. They encountered some problem using Microsoft Access DBMS to support web applications. Usually for any web application, multiple users, they need to access the data concurrently. So that's the typical way people access web applications. But if they use Microsoft Access, because the older version, here I talk about 10-something years ago, the older version, So I noticed some people use the Microsoft DBMS Access. Then they notice if multiple users access the database concurrently, it could be very slow because it does not have the concurrency control, so it has to provide services, one by one in a queue, okay? In a queue. Yeah. So then people waiting in a queue, they need to wait a long time, okay, relatively long time. So they see the response time very slow. Yeah. That's the older way, okay? Yeah. And then older version. Yeah. So then many people complain. Yeah. If they change to a better DBMS, for example, MySQL, they can avoid that problem. Yeah. But those people, they do not want to change. Yeah. So I know. So those people, they want to use the Microsoft Access for small business. Yeah. So then later Microsoft changed that. Okay. So right now they changed to 155. For home business, small business is enough, right? Yeah. For home business, small business, yeah. If it can support 255 concurrent users, then good enough. Yeah. If you have users much more than this number, then you should move to, more powerful DBMS. Okay, MySQL, other larger, more powerful DBMS. Yeah. So then, those people, they won't complain. Okay, so, pretty good. Yeah, 205, quite a lot concurrently. Right? Think about concurrency. Concurrently. Yeah. All right, so that's this feature. Yeah. All right, yeah. So that for web applications. All web applications require this feature for database accesses. Yeah. And the transaction feature requires this feature. Yeah. Concurrency control. Yeah. So without this feature, then the transaction feature has the problem. Yeah. All right, yeah. So this is our second advanced feature. The third one, store the procedures. Another advanced feature for DBM, store the procedures. Yeah, so this one, it's a form of functions with input and output. Yeah. All right, so now, in a DBMS, right now, you can write SQL statements to do SQL queries, right? So every SQL query, you write one SQL statement. Okay. Right now, you understand this part. Okay, yeah. All right. So every time you enter one SQL command, send the query to the DBMS, and the DBMS returns the query result. Yeah. So you understand this part very well. Okay? Yeah. So you are used to this kind of communication with the DBMS. All right. But so when you move to another level higher, you need to do more. Yeah. So here, look at this store the procedure features. So that's a function definition. All right. So you use the SQL statements to define a function. So you know function, yeah. So every programmer, so you know how to write a typical function. Here we need to use the SQL commands to write a function. Okay? Yeah. So all the statements in your function definition, all SQL commands. Okay? Yeah. So then the whole function can do the data processing inside the function. So you have the logic in your function definition. So you can do the data processing, process the input, and generate the output. Input, output, a typical function. And then that function is executed in your DBMS. Okay, yeah, executed in your DBMS using SQL commands. So that's the stored procedure. That's the stored procedure. Okay, yeah, all right. Written in SQL, completely in SQL. Yeah. All right. Execute a sequence of SQL statements in DBMS. Good. All right. Part of database definition. Yeah. So here, this, because you write your code, okay? The function definition, all in SQL. So there, the whole function definition, we treat it as the part of the database definition. Yeah. Because so far, when we understand the database definition, we need to define tables, right? Table by table. Okay? Yeah. Table is our basic database constructs. Okay? Table. Okay? Many tables, sequence of tables. Later, we may define domains for data, for special data types. We may need to define domains using SQL commands. Okay? Then we may define constraints. Yeah. Later we talk about constraints, domains, constraints. Okay? So all part of the database definition. All part of the database definition. And here, store the procedure. Yeah. Store procedure. The, in SQL commands. Another part of this database definition. Okay. So you can define several store procedures, several functions. Store procedures. Okay, and this part we also call metadata. Metadata. Yeah. So what's the metadata? The meaning of the metadata. Okay. Yeah. Metadata. Yeah. So here means descriptive data. You want to describe your data. So the data used, supporting data used to describe your main data, main data, supporting data, descriptive, support your main data, or you call it secondary. Metadata we call it secondary data. You have primary data, right? So your business, you have your business data. So here we have primary and secondary. Okay, so the primary data. What's the primary data? So your business data. That's the primary data, okay? Then you have secondary data. And then this part is the metadata. So what's the metadata? Describe the primary data. Yeah. How to organize your primary data, right? Yeah. How to put some specific structure to organize your primary data. You need to tell the DBMS how to build special structures on your primary data. So that information, so we call it metadata, secondary metadata. Okay? Yeah. All right. And then this part, that's the, this part, the secondary data part, we need to do it in our database definition. So our database definition contains the metadata, the secondary metadata. Okay, all right. Yeah. So then, and then this item, let me explain. can be called locally and remotely from the application programmers. So two ways to call stored procedure. Call what? Can be called. So here we're talking about stored procedures can be called locally. Locally, yeah. So in your GUI interface, you call. So you type the command call, okay? Call procedure name, okay? Yeah. So your function have a name, right? So your procedure, your stored procedure is like a function. So your function has a function name. So you call that function name, then the DBMs execute that function. Okay. You call with input output, with input, then you can get output. Okay. So that's the call locally. Well, another possibility, you call stored procedures remotely. Yeah. Remotely. So what's that? Because we want to use our application program to call a stored procedure. Okay? In our, for example, Java code, PHP code, then we need to execute remote call on a stored procedure. So we write, in some function, we write our SQL command. We send a SQL command to the DBMS. So what's our SQL command? Call certain procedure name. Call procedure name, function name. So then, the procedure executed remotely in the remote database server. Okay? Then we receive the processing result. Yeah. So that's how to use a stored procedure. All right. Yeah. So can be create. Yeah. So you can also you create a stored procedure remotely in application programs. The reason is easy, because in your application program, you can execute any SQL command, right? You can execute a sequence of SQL command. You create a stored procedure using a sequence of SQL commands in your application program. So you create a stored procedure in the application program. Okay? Yeah. So sometimes you need to do that. Yeah. All right. So the last property, can reduce data traffic on internet. Yeah. So this point. Yeah. So this is the benefit of the stored procedure. Yeah. Why this, stored procedure, this advanced feature is very useful. Yeah, so here, this is a benefit. Okay. Can make your business application run faster, because if you can reduce the business traffic, then you can run faster. So here, let me use a diagram to explain why it can reduce data traffic on internet. All right. Here, think about. For a web application, we need to run a web application in a web server, right? So web server here. Then your database usually sit in a different server. So here, let's imagine there is a DB server running your database services. All right. Then in your web applications, you need to call database queries frequently, right? Then the DBMS send the query result back. Okay, all right. Think about it. For a business task. For a business task. Okay, suppose in a business task, you need many queries. You need to do many queries in one particular business task. Think about if every time you need to call the remote DB server to return the result, you need many data transmissions between two servers, right? Yeah. Let's assume, for example, 10 queries. You need to, so in order to complete one particular business task, you need to complete 10 SQL queries. You need to make 10 SQL query calls to the remote DB server, so 10 times, okay? Yeah. Return, call, return, 10 times. Okay. Send the data back, all right? So then, you do the data processing on the return the data, okay? Yeah, the processing. Here, okay? Then you generate the processing result at the end. After 10 queries, so you have the sufficient data you need for your particular business task. So then you generate the final result, okay? But you have a lot of data traffic, right? Yeah. In those 10 queries, there are a lot of data traffic on internet, through internet, okay? All right, so that's the way without using the stored procedure. Another way to do the same thing, but you apply the stored procedure to do the same data processing. Yeah. All right, so in that case, so here, I draw the circle, okay? Yeah, so I draw this one also for DB server. But here we have stored procedure, okay? Yeah, so we write a code, store the procedure, right? This store procedure contains those 10 database queries, okay? Those 10 queries, we write a code, execute in this DBMS, okay? Yeah. Then, in order to do the same data processing, you just make one call, okay? One call that store procedure. So that store procedure does the processing of those 10 queries, then produce the final result and send it back to you. You only receive the final result, and you do not need to receive the intermediate query result, right? Then all the traffic for the intermediate result all can be saved, okay? Yeah. So you reduce the data traffic, because in the remote DB server, it does all the data processing locally, yeah? So in that machine, locally, okay? Yeah. No data transmission during the data processing, yeah. Only at the end, the final result is produced, it sends the final result back. Yeah. So your web server, you just receive the final result. Yeah. So in this way, the data traffic is greatly reduced. So that's the benefit of this store procedure. Okay? That's one benefit. So, So your overall response time of your business application will be faster. Yep, because the less internet traffic, then overall performance will be faster. Okay, yeah, all right. So improve the performance. Then another benefit, enforce business rules. Enforce business rules. Yeah. Because for some business, many times you need to check business rules. If the data received follow certain business rules, if you use the manpower to check business rules, they're not very efficient. So in that situation, you want to write programs to check the business rules automatically. Yeah, so the stored procedure can be used to do that checking. Enforce business rules. Okay, yeah, yeah. So you can see, yeah, it's very useful. Yeah. So the store is very useful. Yeah. And our modern DBMS all support stored procedures. Yeah. So you just need to learn how to write the programs. All right. Yeah. So then, there is another benefit. Yeah. Another benefit. Yeah. So here, before we move to the next topic, I also want to talk about another benefit. Yeah. Because in the current business world, that benefit is also very useful. So I want to talk about a little bit before we move to the next topic. So that's the supporting multiple programming languages. So this feature, another feature is support multiple programming languages. In one web application. Okay, yeah. So let me explain this benefit. Yeah. Yeah. So here we consider a typical web application in the IT industry. Typical web application. Yeah. It's very common. One big application could use multiple programming language. Because, so right now, for one typical web application, usually there are many components, many web components. Okay? And our web application, the structure, the architecture of our web application is in a distributed fashion. Distributed. Yeah. So that is the whole web application contains modules from many servers distributed in the world, many different locations in the world. Yeah. So that's very common. Okay? Yeah. Each module could be written in different programming language. Yeah. So that happens a lot. Different programming languages. Okay? Java, PHP, C#, Python, and many other programming languages. Okay? So, yeah. Yeah, because for each module, usually one module focuses one specific business services. One specific business service. Okay? Then certain programming language is the best for special business services. Right? Yeah. So Then, so your web application should allow different programming languages to implement different web components in the whole web application. Okay, all right. So now, think about for some data processing tasks, those different programming languages, when they need to work on some specific data processing work, okay, data processing work, do you need to implement the same task in different programming languages? Think about that, okay? The data processing task is the same, but because you have several programming languages, do you need to write the same task in all those different programming languages, all the versions? You can do that, but that's not efficient, okay? Because the same data processing task, you may need to use 5 different programming languages to write 5 different versions, okay? Java version, PHP version, C# version, Python version, right? And several other language versions. So that's not efficient, right? When you maintain all these data processing tasks, it's not efficient, okay? So then a better way to make it more efficient is you use the SQL to store the procedure for the data processing, right? So that in your DBMS, store the procedure, implement it in SQL statements. Then all these 5 programming languages, different programming languages, they just call the same stored procedure to complete one business task. Not get a result. So they do not need to write their own version, right? So those 5 different programming languages, they can use one common version, SQL version to do the, database intensive data processing. So that's another benefit. So that benefit is also very important, because in current industry, so that way is very useful. All right. So here you can see these 3 advanced features inside DBMS. So very useful, very important. So after you get experience on the basic SQL queries, sooner or later you need to move to these advanced features. Sooner or later. Okay. All right. Then let's move to next topic, 8.2, basic database concepts. Define a database. Now we have seen several components we need to do when we define a database. Database definition, I mentioned that before. All right, so how to specify a database? Structure, define structure, table structure, define tables, sequence of tables. Structure, describe the structure. Data types, so the data you use, then you need to describe your data types. Then constraints of data, certain conditions must be satisfied. So the DBMS has built-in ways to define constraints of data. So we will see that later. But usually for relatively simple constraint, when you use the database built-in way to define constraints, relatively the simple way. Complex way, you need to use stored procedure. if the complex with the built-in constraint cannot make it, okay? Too complicated. Yeah. So the built-in constraint only for very simple constraints. Yeah. All right. Then metadata. So the metadata I already explained, descriptive data for data. Okay. Refers to database definition. Yeah. So definition. Yeah. So I mentioned several components. Yeah. All right. Yeah. Stored by DBMS in the form of database catalog and a dictionary. Here, you see this concept, database catalog. What's the catalog? Also called a dictionary. Okay. Yeah. The catalog, so database catalog, a whole block of special location used to store the database scriptive data, okay, metadata, scriptive. So that data is stored in the catalog, okay? The metadata, descriptive data of your business data is stored in the catalog. Yeah. So also you can call dictionary. So the database catalog. Yeah. So the metadata stored in the catalog separated from your business data. Yeah. Separated, not mixed. Yeah. Separated. All right. Then the database system. Database, when we say database system, we mean database and a DBMS software together. The database, that's the business data. The business data with certain structure, so that's the database part. Then managing those databases, you need a DBMS. So putting together, so we call it database system. Yeah. All right. Yeah. So in this diagram, so this diagram so give you an idea. We are here, we are programmers. Okay? So we need to write programs to, do the communications with the DBMS. Then the bottom data, you can see two separate cylinders, two parts. The data is separated, two blocks, two cylinders here. Store the database, so this is the business data, okay? This is your business data, okay? Also called the primary data. Yeah. So this store the database definition metadata, so this is the secondary data, metadata, but the descriptive secondary data. So you can see their storage separated. Two different places. Yeah. Then you need to write application program. You use high-level web programming languages typically. So here we imagine. So we are writing our web applications here. In your web applications, you need to do SQL queries. All right. Then, so the DBMS software in the middle layer, you can see the DBMS software, the role, it's in the middle layer between application programmers and your business data, the data layer, okay? So the supporting data, metadata, that's the supporting data. The data layer and the programmer coding layer, right? You need to write a code program. Then in the middle, DBMS layer. Okay? Yeah. All right. So the software to process queries, yeah, and the software to access stored data. Yeah. For the communication part. Yeah. And then the software process queries. So here, let's look at a process query. how to process the queries, right? Yeah. So you may like to know how to process the queries. Queries, SQL commands. So here, our typical queries in SQL statements or commands. Okay, yeah. So we know the commands, it's in text format, right? Yeah. So you write your SQL statements. That's the text format. Okay, yeah. For text format, you know, the text commands need to be converted to machine code, right? Yeah. The text code cannot be executed directly, right? Yeah. So then, in order to execute your SQL commands, the DBMS needs to do one thing: compilation, compile. It's a command. You need to do compilation. Okay? Yeah. Compilation. Compile your SQL commands. After compilation, you get a machine code, binary, executable. Okay? So you get an executable machine code. Machine code. Yeah. So then, the binary executable machine code, then executed. Yeah. Because you want your SQL command executed very fast. Yeah. So it's the final execution form, it's the binary form. Yeah. So then you get a processing result. But that step hidden, okay, you cannot see it. It happens behind the scene, the compilation, you know, all the lower level work hidden. You cannot see. You may not realize it. Yeah. But when you send a command to a DBMS remote database server, yeah, after it receives that, it needs to compile, convert it to machine code internally. Yeah. Yeah. So then, next time when you call the command, it just executes the compiled machine code one by one. But when you call a particular SQL command, SQL statement, then it calls the machine code, machine instruction. So that kind of understanding. Yeah. All right. Yeah. All right. So we almost run out of time. So the last slide, this last slide of this part, let me leave to the beginning of next class. Next class, I just complete this last slide talking about application programs. So what we need to do. Actually, we saw part of it in the previous slides. Yeah. So this last one I just treat as a summary. Okay. So what we can do in application programs. Yeah. Actually, how many minutes? Yeah, only 2 minutes. Yeah. Let's leave to the next time. Yeah. I may need 5 minutes to complete it. Yeah. All right. So that's it. Yeah.